In section 1-2, we're going to be talking about domain and range. So this is an example where you're going to pause this video and you're going to write all of this down and then come back and listen to me. So go ahead and pause and do that. So when we talk about domain, most functions have a domain of all real numbers. The restrictions come in when you have a rational function or a radical function and then any combination of those two together. So for rational functions, I have indicated that the top is n of x for numerator, the bottom is d of x for denominator. Now, if you don't have any x's in those places, then you don't really have to be concerned about the restriction. But if there is a variable in the denominator specifically, any value that's going to make that equal to 0 cannot be included in the domain. We know from previous math classes that this gives you a vertical asymptote. So in order to figure out what this domain restriction is, you set the denominator not equal to 0. So these are the excluded values. Now we're going to do examples of this in a minute, but the excluded values are not part of the domain. Everything else is included. All right, so then secondly, you can have radical functions. So this is where you have a square root symbol, and then you have a function underneath it. So if you've got x's under there, then you have to pay attention to what your index is. Now the index is the number that's on the outside right here. So if that is odd, so if it's the third root, fifth root, seventh root, then you don't have to worry about a restriction because there isn't one. But if it's even, then whatever is up underneath that radical has to be greater than or equal to 0. And this comes from the fact that since you are taking the square root of negative numbers, you will end up with imaginary values. So those can't be in the domain either. So an even index in a denominator, so that's the combination of those two together, then whatever is under that radical in the denominator would have to be greater than 0. So let's do a few examples of this. All right, so my first example says to find the domain of this. So this is an example where I have the numerator and the denominator. So what I have to know and understand is that the denominator cannot be equal to 0. So if my denominator is x minus 4, then it cannot be equal to 0. And to solve that for x, I get that x cannot be equal to the number 4. Now, when you write these in general, they're going to be in interval notation. So I know that 4 cannot be part of my domain. All right, and that's the only excluded value there is. So that means that anything over here is part of the domain, and that goes on forever. And anything to the right, and it goes on forever, is part of the domain. So the domain for this would be the interval from negative infinity up to 4. I cannot include the 4, and you never include infinities. And then there's a union because I have to pick back up at 4 and go to infinity. Now, I can't write that as negative infinity to positive infinity because the number 4 has to be excluded. Next example we have is a rational function within that has a radical within it. All right, so I have n of x and I have d of x. Again, numerator and denominator. So my concern is that number 1, d of x, the denominator, cannot be equal to 0. So my denominator is x minus 4 cannot be equal to 0. So that means that x cannot be equal to 4. And then this one has an additional situation because I have a radical. So because it's a radical, then I know that what's up underneath the radical has to be greater than or equal to 0. And the reason I can say that it can be equal to 0 is because it is in the numerator. So a numerator can be 0, a denominator cannot be. So a numerator can be equal to 0, so that's why we have this included symbol. So x has to be greater than or equal to negative 2. So I have to have both of those things occurring at the exact same time. So on my number line, I'm going to need to have the number negative 2, and I'm also going to have the number 4. Now, I know it cannot be equal to 4, And then this part says that x has to be greater than or equal to negative 2. So what that means is there's no part of it that can go over this way. This says greater than or equal to negative 2. So I can be equal at negative 2, and then I have to shade this way, but I have to not include the 4. So I skip over it and I keep going, and it is shaded all the way to the right. So when I write this in interval notation, I'm going to start at negative 2 with a bracket because I do include the negative 2. I go up to but do not include the 4. And then I have a union because I have to omit and eliminate the number 4. And then it goes on forever. Next example that I have says to find the domain of this rational function. So x plus 7 will not do anything else. However, in the bottom, I need to factor if I can, and this will in fact factor. I have x plus 5 and then x minus 3. Now, if anything were canceled out right here, that would mean that you have a whole, and that means that it cannot be included in the domain because that is a point discontinuity. We do not have that situation. So the only domain restriction for this is that the denominator cannot be equal to 0. So my denominator in factored form says x plus 5 times x minus 3 cannot be equal to 0. So in order to solve that, I have x plus 5 cannot be equal to 0. X minus 3 cannot be equal to 0. So I have that x cannot be equal to negative 5. I also have that x cannot be equal to the number 3. So as I put this on a number line, I will have the situation where I need both of those numbers on the number line. Make sure that you put them in the appropriate order. Sometimes it helps kids to kind of have a place where I'm looking at 0, so I know that I've got my positives and negatives in the appropriate order. All right, this says that x cannot be equal to negative 5, so that doesn't work. And I also know that x cannot be equal to 3. Now, the 0 is on there merely for the fact that I'm making sure everything's in order, so you can erase that once you know that they're in the proper place. Now, this one is different because it cuts the number line into this section first, the middle section, and then the section to the right. So when I write this domain, it will go from negative infinity to negative 5. I do not include either one of those. And then I have a union because I have to consider my middle section, which goes from negative 5 to 3. And then I have another union because I'm going and starting again at 3, and I'm going to infinity. So this would be the domain for this equation. This graph was taken directly from your homework, all right, and I copy and pasted it on here. So I'm going to enlarge it just a little bit. So this one is asking me to talk about what the domain of this is. So what we have to do for a domain is go from left to right, okay? So this equation, or this graphed curve rather, starts at negative 5 and it continues all the way over until I get to the number 3. Now what I have to be very careful of is that this is an open circle, so that is equivalent to saying that I have an open end point at negative 5, and then it continues until I get over here at the 3, and this is a closed end point. So I go negative 5 to 3, and 3 has a bracket with it. So be very careful about whether you have open or closed endpoints. This is another one that's been copied and pasted from your homework. So again, this one is asking for two things. First off, it wants domain. So I'm going to do it in green just like I did on the last one. So in green, this from left to right starts at negative 1, and it goes until it hits this open endpoint at 3. Now, because this is closed, that will have to start with a bracket at negative 1. This, however, is open, and the x value that's equivalent to that is the number 3, and that will be an open endpoint. So I need to have a parenthesis instead of a bracket. All right, now for range. When you do range, you have to go bottom to top. So if I look at the y value, this ordered pair point is at a y value of negative 5, and it is open. So I use a parenthesis. So I go from negative 5. and then I'm looking at the highest y value that this thing ever takes on, and that would be right here at this ordered pair point, and that will be a 4, and that ordered pair point is part of the graph, so this has to be included. This is a bracket, so be sure that you are paying very close attention to whether it is open or closed. The next portion of this is talking about piecewise functions. So when you're given a piecewise function, you have the scenario, you can see it underneath this, but what I'm talking about is you have one portion that tells you what the equation is, and then the right-hand side is going to tell you what your domain is. So you have to be very careful to ensure that you know what domain section you're talking about when you're doing these, so that you're looking at the right part of it. So let's look at an example of this. This one is asking me to calculate f of -1. So what I have to do is come up here, and I'm looking at this in pink or this in blue. So I've got to figure out which one of these does -1 belong to. So -1 is going to be less than 0, so this is going to be in that pink domain. Well, the portion of it that is an equation that goes with that domain is 6x minus 4. So I'm going to do 6, and then my x value is -1 minus 4. So I have -6 minus 4, so that's going to give me -10. All right, next portion is asking me for f of 0. So when I'm looking at this and I come up here, well, the top one says x is less than 0, which means it's not equal to 0. So when I look at this one, I see that I've got this equal to sign. So this is where x is equal to 0. So if I'm looking at f of 0, then I'm going to be using this equation. So I have, this is going to be 6 times my x value, which is 0, and I'm going to subtract 8 from that, so that gives me -8 as my answer. Last part of this says f of 2. So as I look at this, I'm trying to decide which section does this belong to. So 2 is greater than or equal to 0. So this again is going to be the blue function. So as I do this, I'm going to have the 6 and then the x value, which in this case is 2. And I'm going to subtract 8 from it. So 12 minus 8 will give me an answer of 4. You have to decide which domain fits first, and then you want to go through and do the substitution for the function itself. So this graph is also copy and pasted, and with this one, it is telling you that you are going to be looking at this says to write the equation. It's not actually the equation. You're actually going to be writing the domain for these. Okay, so as I look at this graph, I've got 3 different sections. And with these 3 sections, I'm going to talk about these one at a time. So this one says when y is equal to 4. Well, the piece that goes and is y is equal to 4 goes from here to here. That's the y value of 4. So the x values that go with that are going to be here at -6, and it's going to go up to 2. Now, both of these ordered pair points on the ends are closed in circles. So when we write this, we're going to have x is an element of, that's what that little weird looking e looks like, or is said. X is an element of. So I have closed in points, so this is going to go from -6 to -2. You always go left to right. And then we're now going to go over to the one that is at a y value of 2. Okay, so that is this section right here. And as I'm reading through that, I'm seeing this and I'm saying, okay, this is an open endpoint. All right, so that's going to be right here at -2. This one is a closed endpoint, and it is right here at 1. So as I write this down, I'm going to go from -2 to 1. As I'm looking at -2, it's an open endpoint, so we use a parenthesis, and at 1 is a closed endpoint, so we use a bracket. Last but not least, we have a y value of -5, and the graph that does this goes from here to here, because that is a y value of -5. So as I'm looking through that, this goes from -1, and then it stops here at 4. This one is a closed endpoint. This one is an open endpoint. So if I start to the left of this, I'm going to start at 1, and then I go to the right, and it stops at an x value of 4. 1 is an open endpoint, so I use a parenthesis, and 4 is a closed endpoint, so I use a bracket. This one is giving us what our domains are. It's telling us what x is between, and it wants you to come up with the equations. So I'm going to do these in the same color ink as the graph. So for the first section, I have blue. All right, I'm going between an x value of -6 and -1. Now, I don't know, this is not a horizontal line. It's not like the other one. I also don't see where my y-intercept is going to be. So what I'm going to do is choose this ordered pair point, which is at -5, +3. And I'm going to choose this endpoint, which is at -3, 4. And I'm going to count my slope, so that's going to make my life a little easier. I go up 1 and I go right 2. All right, so my slope is 1/2. And then I have to come up with my y-intercept. So most of you all, I feel like, did y equals mx plus b. So this is y is equal to 1/2 x plus b. And then I use one of the two ordered pair points. So I'm going to use 3 is equal to 1/2 times -5 over 1 plus b. So I have 3 over 1, getting a common denominator. And this is going to be -5/2. So I'm now going to add 5/2 to that side to get my y-intercept. So I have 6/2 plus 5/2 is going to give me 11/2. So my y-intercept is at 11/2. So my equation that will go right here is going to be y is equal to 1/2 x plus 11/2. So that would go right there when you type this in online. All right, when I look at the green one, it is a horizontal line. So as I look at the green one, there's not anything that I have to come up with. I just know that regardless what my x's are, my y value is going to be the number 4, and that section is now complete. So when we go through and we do the last one, the yellow, I'm going to erase this set of equations because we have to now go do the other one, the yellow one. And as I look at this yellow one, I have ordered pair points at 2, 3. I have another ordered pair point in several places. I'm going to use the other end point. So I have 6, -3. I can count my slope or I can go find it. So let's say we don't like to count it. We're going to do -3 minus 3 over 6 minus 2. So that's going to give me -6 divided by 4, which reduces to -3/2. You get the same thing if you counted rise over run. And now we're going to use y is equal to my slope, x plus b. So then we're choosing one of the two ordered pair points. And I'm going to use the first one that we wrote down. So I have 3 is equal to -3/2 times 2 plus b. This is 2 over 1, so my 2's cancel. I have 3 is equal to -3 plus b. So this gives me that b is equal to 6. So the equation that will go right here is y is equal to -3/2 x plus 6. When you get on these online piecewise graphing questions, you need to be careful about not putting an ordered pair point, like an actual dot, where the equation changes and it's still continuous. There are 2 of these on your homework, and if you miss it with getting most of your points, then bring it to me or email me and ask me to look at it for you, and that will make your lives a little bit easier. So we're going to go through and we're going to graph this thing. So the first one I'm going to do is this one. This tells me that the domain of this starts at -1. So I'm down here and I have to start at -1. And it tells me that my y value is at -1. So when we plot that ordered pair point, it's equal to, so this is a closed circle. This line right here makes that into a closed ordered pair point. So then I know that regardless what x I use to the left of that, I have to have a y value of -1. So this line is a horizontal line that goes to the left. All right, I'm going to skip down and do the bottom one now. So for this one, we have a domain value of x is greater than 2. So I come down here in green, and I'm looking at an x value of 2, and my y value is 4. So this one does not have the line to tell me that it's equal to. So this is open. And again, it's just a horizontal line that continues on forever. Now what we've got to take time and do is the in-between one. So I'm going to do it just in regular black ink. I have, as long as I'm going at an x value between -1 and +2. So I only need the endpoints to connect them together. If you want to do a third ordered pair point, you can, but it's not necessary. I have 2x plus 1. So if I start at -1, I have 2 times -1 plus 1. So that's going to give me -2 plus 1 gives me -1 as my y value. So that means I go to -1 and -1. And I would put a open ordered pair point. Well, the thing is, that's already open. It's already closed, so you can't reopen it. So if you want to make a notation there for yourself, but it is already closed, so you don't open it back up. So if I go through and I do 2 times 2 plus 1, that's going to give me the number 5. So I go over to 2 and I go up to 5, and this one does have this solid line. So I do put a closed dot. Now, as long as I connect those two together, that's all I have to do to get that middle portion. And this is what I'm talking about right here. You don't want to have an ordered pair point right here, okay? This is just going to go across this way, and then it's going to connect to this. There won't be an ordered pair point when you do this online. You're probably going to need some help with these graphs. So if you have a question when you're doing it, just let me know. Come up and ask me, and I will give you some assistance. And this is the last one where we are going to be graphing this again. The only one this time that gives me an abbreviated section to look at is this one. All right, we have y is equal to -3 as long as my x goes between -4 and 2. So if I go to graph that, I start at -4 and I go I go down to -3, and that is going to be an open endpoint. Okay. And then I have to go over to +2, and I'm also down at -3, and I would have a closed endpoint. And this is the horizontal line. Now I start with that one because it's the easiest one. All right, at that point you can go to either one of the other two. I'm going to go to the bottom one. All right, I have 2x minus 7 as long as x is greater than 2. So I'm going to come up here and we're going to work through this. We have x is equal to 2. So if I have 2x minus 7, that means I've got 2 times 2 minus 7, which is going to give me the number -3. So if I go right 2 and down -3, then I have an open circle. But again, it's already closed, so I can't reopen it. So this is going to be one of those situations where you won't have an ordered pair point there. Now, I'm looking for x's that are greater than 2, so I'm going to put a 3 in there and see what happens. So I have 2 times 3, and then I have a subtraction of 7. So 6 minus 7 gives me -1. So if I go over 3, I'll go down to -1, and what would happen is that this is just going to continue. Okay, and again, this is going to erase way too much, but this does not need to have an ordered pair point right here. So you're going to keep this going across, and then it will go up where the blue goes up without an ordered pair point. Last but not least, we're going to do the top one. So I have to have x is less than or equal to -4. So I'm going to plug a -4 in here. I have -3/2 or -1.5. X minus 5. So as I'm doing this, I've got negative 3/2 times negative 4. And then I'm going to subtract 5 from it. So negative times a negative is going to make it a positive. 2 goes into 4 twice. So I have 6 minus 5. That's going to give me a 1. So I go negative 4, positive 1. And I know that that is a closed circle. And then I have a slope of negative 3/2. So I could go up 1, 2, 3. And then I go left 2. And I can do it that way. Alternatively, if you don't want to count that, you can also put a negative 6 in here. And the reason I'm choosing negative 6 is because 2 will go into it, so that makes my calculation easier. So 2 goes into 6 3 times. A negative makes it positive. And I will have 3 times 3 is 9, minus 5 would give me the 4. So I still end up at that exact same place. So if you have any questions, just let me know.